Hello everyone. Today we will be discussing the 2024 February-March paper 5-2. So before I proceed with the discussion, I would like to give a disclaimer that the question paper is not owned by the GT Chem channel and the owner, and answer discussed in this question paper is not the marking scheme by Cambridge Assessment International Education. Whatever answers you'll be seeing is just the opinion of the author and is used for discussion purposes only. Without further ado, we shall look at the paper. All right. Now, so let me just scroll up to show you that this is the 2024 February-March paper 5-2. Question number 1. Seawater contains about 20 grams per dm cube of chloride ions. The exact concentration of the chloride in the seawater can be determined by titration with aqueous silver using aqueous potassium chromate as an indicator. So when aqueous silver nitrate is added to a sample of seawater, silver ions will react with the chloride ions to form a precipitate of silver chloride. When all the chloride has reacted with silver, the presence of unreacted silver ions is detected by chromate. A red precipitate of silver chromate is seen. The amount of silver reacting with chloride in a sample of seawater can be calculated in order to determine the concentration of chloride in the sample of water. So a student uses the following method. Number 1, use a weighing boat to weigh by difference approximately 10.6 grams of silver nitrate solid into a 100 centimeter cube of glass beaker. Initially, you weigh in weighing boat. After that, you need to transfer to a 100 centimeter cube of beaker. 2. Use the sample of silver nitrate to prepare a 250 solution of the silver nitrate. Number 3, transfer this solution into a dark brown glass bottle. Label this as X in the dark brown glass bottle. All right, so your solution X is your silver nitrate solution. Okay, so this one here, okay, is actually your silver nitrate solution, which is here. Collect a sample of seawater and remove any solid material present, because see, there's a lot of things inside the seawater. Step 5, transfer 10 centimeter cube of the seawater into a conical flask. Add 1 centimeter cube of potassium chromate, that would be the indicator, into the conical flask. Step 7, rinse a burette in preparation for the titration. Fill the burette with solution X. So you can see in my drawing, the burette is already filled with solution X, which is your silver nitrate solution. Slowly add the solution X to the conical flask until the white PPT turns red. Now, let's look at what is going on over here. Okay, so you can actually look at the drawing as well as the step 1 to step 6. All right, so everybody, you can look at the top conical flask that I've drawn or the bottom right corner. So in the conical flask, right, you already put the seawater, which is the blue color highlighter chloride, and you put 1 centimeter cube of the potassium chromate in. So in the conical flask, you can see you already put these two. Now, these two ions are in two different equations. All right, they won't react first. Both are negative charge. The minute you start titrating with the silver ions, from the burette, when it drops the silver first will react with the chloride to form the white PPT here. The first equation will run when you start titrating. Okay, yeah. Now, therefore, you will see a lot of white PPT. Now, the minute chloride has been fully utilized, whatever chloride, the seawater in a conical flask has been fully utilized, any excess silver that is being run down in the burette do not have any more chloride. Hence, the second equation will run. Because they got no more chloride anymore, the silver will react with the chromate. Then only your red PPT will be formed. So what the chromate does is they actually detect the excess silver ion that do not have any more chloride to react. Okay? Now, so describe how the student should carry out step 1. Include a table in your answer to show how this process is recorded. So if you look at step 1, okay, you are supposed to use a weighing board. So you want to measure by difference. So my table, all right, I just use the dotted line there as the grid, okay, conveniently for me. Number one, I said measure the mass of an empty weighing boat, and I put the unit there, gram. And let's assume that is an X, okay? I don't know what's the number. Then you measure the mass of the weighing boat, this time with the silver nitrate solid in, also unit gram. And this will be heavier, of course, which is I give a value called Y. Weigh by difference means you need to subtract the two numbers. So the mass of silver nitrate used is actually the bigger number Y minus the smaller number, which will give approximately around 10.6. Alright, so you can see the instruction over here. They say approximately 10.6 and you weigh it by difference. Okay. Okay, let's look at part B. Describe how the student should prepare 250 centimeter cube of silver nitrate in step 2, starting with the silver nitrate solid in the 100 centimeter cube of beaker in step 1. So that means the silver nitrate solid is already in your 100 centimeter cube beaker and you start from there. Okay, so first, add some distilled water into the beaker containing your silver nitrate and dissolve the solid. Okay, so maybe you want to say stir. Okay, but I don't think stirring will have a mark, but normally is to add distilled water to dissolve it. Now then, you pour the solution into a 250 volumetric flask. Okay, the capacity need to write properly because you want to prepare a 250 silver nitrate. Okay, so you want to use a 250 volumetric flask. Now, rinse the beaker with distilled water and pour the washing into the volumetric flask. Okay, because when you pour from the beaker to the volumetric flask, there are some silver nitrate in the beaker at the inner wall. So you need to rinse the inner wall of the beaker and pour the washing into the volumetric flask. Okay, fill the volumetric flask with distilled water until the mark. The mark is the 250 mark. All right, close the flask and invert round. Okay, so normally they want to see like a couple of few bullet points here, then you will score 3 marks total. All right, part C. Suggest why solution X is kept in a dark brown glass bottle in step 3 rather than a colorless glass bottle. All right, now, the reason why we kept in a brown bottle is because we want to prevent or reduce the light to reach the solution. So for me, my answer would be silver ions is light sensitive. Okay, that's the main reason. So anything that is light sensitive, right, we will put it in a dark bottle. Okay, now, why do, or what does light do to silver ions? Okay, this one, right, a couple of few answers. Okay, so for me, without thinking too much, maybe light can reduce your silver plus into a silver metal. Then you start to see some, precipitation in the bottle. All right, or sometimes there is also another thing called hydrolysis of the silver nitrate into silver oxide. Okay, the silver oxide is a brown or black kind of PPT. Now, I think the more easy one that you all would be able to think of is reduction of silver plus into silver metal. Okay, I don't think anyone will think about the hydrolysis of silver ions because I don't think that is in your syllabus. Okay, but not too sure what will be the marking scheme answer. Okay, but I guess marks should be awarded to at least address that silver ion is light sensitive or to prevent light from reaching silver ions. Okay, because a reaction can occur. So some students say that, oh, light can decompose silver nitrate. Okay, how true is that? We do not know. All right, so my personal opinion is we do not know what exactly is the reaction. Okay, and I hope the marking scheme is only awarding that 1 mark to address that it's sensitive to light or to prevent light to reach the silver ions. All right, because what can silver do with light is not in the syllabus. So it's basically a wild guess. Okay, so if you're unlucky, then perhaps they really want to see a particular reaction, and if you never write a particular reaction there, then you won't get your mark. But I hope they just award to prevent light or silver plus is light sensitive. Okay, so what is the actual answer? Do not know, but that's just my personal opinion. Okay, now donkey. Suggest how solid material should be removed from seawater in step 4. Use a filter. Okay. Now, some students say use a funnel. Funnel not sufficient enough because funnel, we use funnel to fill in the solution into our burette. So funnel, you can see there's a very big hole. There is no porous. So no porous means you cannot filter effectively. You literally allow everything to flow into the burette or the beaker if you put the funnel inside the beaker or your conical flask. All right. So use a filter. Okay. E. Identify the most appropriate piece of equipment that you would use to, number 1, transfer 10 centimeter cube of seawater from the dark brown bottle to a conical flask in step 5. Now, the main thing is you want to transfer seawater into the conical flask for your titration. When you want to transfer solution, you should know you use a pipette. But because they wanted 10 centimeter cube, please use a 10 centimeter cube of pipette. Be it volumetric, be it graduated pipette, not very important. Okay, but however, I did realize that they wanted 2 decimal place. So some students, they actually fall for it and write burette because they think it's a 2 decimal place. Okay, now normally extraction of liquid, all right, or transferring of liquid, right, into a conical flask, we use a pipette lah, all right. So perhaps to come up with such an accuracy where you are as accurate as 2 decimal place, perhaps you may need to use a graduated pipette. But then again, you don't learn what is the error on a graduated pipette versus a error on a volumetric pipette. You see, so you just need to write a 10 centimeter cube pipette will do. Now the next thing you may want to ask is burette accepted? Considering the fact that it's 2 decimal place, there's a possibility, all right, but it really depends on the examiner on how they look at it. But for me, no, because normally transferring of solution into conical flask is pipette. Even though it's 2 decimal place, right? We don't transfer solution from one place to another place using a burette. Burette function normally is to react one, not for transferring. Okay, that's just my opinion. But there's this one question I realize is a little bit weird to me is seawater, right? Why did you transfer seawater from dark brown bottle? Because the dark brown bottle I thought is used to contain your solution X, which is silver nitrate, which is like sensitive. It seems when seawater was from the dark brown bottle. It's just, I don't know. All right, but nevertheless, it will not affect our final answer. Okay, now E part 2. Add 1 centimeter cube of the potassium chromate into the conical flask. Okay, now for me, it's measuring cylinder. Okay, some of you make the decision based on, oh, there's no decimal place. Hence, I suggest measuring cylinder. Yes, it's a way out. All right, but more importantly is chromate function is to be there to detect the excess silver plus. Okay, so the concentration or the volume of the chromate is not very important because he was just there waiting for the silver chloride to form completely. Then when all the chloride has been used, whatever silver that comes down will start reacting with me. So I'm just there, I'm the chromate, I'm just there to wait for the silver to come down. So the concentration is not very important. It's because the first silver plus to detect or react with the chromate ion will form the first reactivity. So I don't think the volume is very important for your chromate ions. So you can just use a not so accurate apparatus called a measuring cylinder. Okay, so as you can see in the bracket, right, I wrote as chromate is used to react with the excess silver plus ion over here. All right, the one in bracket here. Now, question F. Chromate solutions are known to be carcinogenic. All right. State what precaution should be taken when using potassium dichromate aqueous in step 6 other than wearing safety goggles. So please write wear chemically resistant glove. Please don't go and just write wear glove. What kind of glove you want? Need to be specific. Okay, even though I know logically when we think of glove, we will assume the glove is the nitrile glove. All right, but if you look at marking scheme, you need to be very clear in exam to write what kind of glove you want. Otherwise, what kind of glove? Winter glove. Okay, so yeah, so wear chemically resistant glove. All right, part G. State what the burette should be rinsed with in step 7. Step 7, all right, is to put your solution X, which is silver nitrate, in the burette. So you should rinse your burette with the solution that you want to contain. So you should use solution X to rinse it first. Then only you properly pour the solution X into the burette. Okay? Now, part F. The student obtained the result shown in table 1.1. All right, you have a final volume, initial volume, and the titer. Okay, now when you want to calculate, okay, the titer, all right, every reading here, because they use a burette, right, is to 2 decimal place. So burette reading must be 2 decimal place. So hence your answer must also be in 2 decimal place, please. Okay, now then you find the difference between the titers of the initial and the final, and you'll be able to get these 4 answers out. Part 2, calculate the mean titer. Now, for those who are still unclear, all right, to calculate an average titer or a mean titer, you can only use titration. All right, that means you can only pick any number from the left to the right. All right, so when you want to calculate the average or mean titer, all right, you can only use titration 1, 2, 3. In other words, titer onwards. Cannot use rough titration in your mean calculation. Cannot. Okay, because rough is just for you to gauge. All right, but titration, it's you add drop wise nearing to the endpoint. Because rough titration was carried out by running. Running means you did not do drop wise. Titration means you run drop wise nearing the endpoint. Okay, so working must be shown. They already state clearly shown your working here. All right, showing your working. So you only can take concordant titer. What is concordant titers? 0.10 difference. So you only can take titration 1 and titration 3. Can you see I put a tick here? I put a tick in blue color in titration 1 and I put a tick at titration 3 because titration 1 and titration 3 are concordant titer. You have to omit out titration 2. Okay, now next. Use the mean titer from H1 to calculate the concentration of chloride ion in a sample of seawater. Bombastic 3 marks. Okay. Assume the mass of solid nitrate used in step 2 was 10.62. Okay. Now, first, density of chloride was given as 20 gram per dm cube. Okay. And you dissolve 10.62 in 250. So please follow my highlighter. Okay. 250 volumetric flask, you dissolve 10.62 gram. So therefore, what is 1000 centimeter cube in terms of ratio? How many gram? So therefore, if you follow the ratio, you are able to get 42.48 for 1000 centimeter cube. Go ratio base. Okay. The reason why I go by 1000 is because I want to find mole per dm cube. 1 dm cube is 1000 centimeter cube. Okay. Now, the formula, all right, this is a very common formula that you need to know. If you want to find mole per dm cube, please look here. Look at where I'm boxing out here. Mole per dm cube is defined as density, which is gram per dm cube, divided by molar mass. Molar mass is gram per dm cube. So if you look at this formula, this gram and this gram can cancel, okay? And therefore, your, oh, sorry, gram per mole. My bad. Gram per mole. Okay, so this gram and this gram can cut. The mole down there, you can bring it up. Therefore, it gives you mole per dm cube on the left-hand side. Okay, so concentration in mole per dm cube is defined as gram per dm cube divided by molar mass, which is having a unit called gram per mole. So if you want to find the concentration of silver nitrate in mole per dm cube, you have to take the density, which is in 1 dm cube, which I calculated 42.48 here, in 1 dm cube, and you divide it by the molar mass of silver nitrate, which is 169.9. Hence, the number of mole per dm cube calculated is 0.250. That's the concentration of silver nitrate. Okay, mole per dm cube. Next, I calculate the moles of silver. Okay, now the titer was 22.40, and I calculate with the and multiply with the concentration of 0.25. All right, divide by 1000. Hence, the number of mole of silver is 5.6 times 10 to the power negative 3. Okay, but this 5.6 is in 10 centimeter cube. Why 10? Read the instruction again. You transfer 10 centimeter cube into the conical flask. That means you are only titrating 10 centimeter cube. Okay, yeah. So we calculated that the silver ions mole is 5.6 times 10 to the power negative 3. Knowing the equation where silver plus and chloride minus to give 1 silver chloride precipitate, if you know the number of moles here is 5.6 times 10 to the power negative 3, the number of moles of chloride is also 5.6 times 10 to the power negative 3, which is this part here. Okay, now the chloride here is in 10 centimeter cube in a conical flask. Okay, just to make things a bit more clear. Now then I need to find what is 1000 because again you want mole per dm cube. All right, so I want to find what is 1000. So 1000 centimeter cube, you go by ratio, you calculate the concentration as 0.560. Okay, yeah, because you calculated 0.560 means the mole is 0.560. But when you divide by 1 dm cube, the concentration is 0.560 mole per dm cube. Okay, still not too bad, but quite a substantial amount of working is needed. All right, so feel free to pause the video here and to go and copy down and check your answers. All right, now part 4, calculate the percentage error in the titer of titration 2. So show your working. So percentage error in titer equals to the error of the burette. Okay, so burette error, you should know, positive minus or plus minus 0.05. And you read the burette 2 times because you read initial, you read final. Every time you read, you may make a positive minus 0.05 error. When you read 2 times, that means you have a possibility of making 2 times error. Okay, divided by the titer. Now, according to 2023 marking scheme, right, I realized that you need to clearly show 0.05 times 2. Yes, some students, they do 0.10 divided by 22.60. The answer will still come out the same. Yes, it will still come out the same. But this is not acceptable. Why? Because the student did not show the examiner that he or she knows that the error is 0.05 and you make 2 times reading. Okay, for all you know, the student think the error on the burette is 0.10 and you took 1 reading, even though mathematically it's the same. So you must show very clearly what is the error on the burette, multiply by the times you read the burette. Okay, so this is a mandatory now. Now, question I. Okay, now question I, you can see I circled it, right? This one, honestly speaking, not too very sure. Okay, but if I have to answer, probably I can just give an answer, but please just take it as a pinch of salt. All right. Spectroscopy analysis of the sample of seawater accurately determine the concentration of chloride to be lower than that determined by titration. Suggests why the student method gave a higher value. It means that when we do this whole experiment, our chloride concentration calculated was higher, whereas spectroscopy was lower. And why is that so? Now, honestly speaking, I really, really no idea. All right, but I've collected some response. All right, so well, I only can give you some opinions I've collected. All right, so some say that because of human error in determining exactly when the white PPT turns red. Okay, yeah. So because when you start the titration, right, you will form silver chloride white PPT. It's gonna be white, all right, like milk. Okay, now then white, and when the first red solid drops in, I think it's gonna be quite obvious lah, because white and a red PPT, I think it's obvious. As compared to colorless to the first red, all right, because a colorless and the first red will make it very pale pink. Yes, I know that is a very obvious difficulty in determining exactly is this the true red, because it's going to be too faint and some of us can't really detect the first red because it's too faint. That one, yes, it's difficult. But white color to red color, when you have a proper white and you want to see the first drop of red, I think it shouldn't be that big of a challenge. All right. Hence, maybe this is not also the answer lah. All right. But considering the fact that couldn't even think of any other thing, so probably, I'll just toss this answer in, or perhaps I'll just leave it blank. Okay, yeah. So We shall see what is the actual marking scheme by the examiner. All right, so this will be question number 1. Let's move to question number 2. A student wants to investigate the rate of hydrolysis of methyl metanoate. The reaction is catalyzed by dilute HCl. So obviously this is an acidic hydrolysis. All right, and you need to hit under reflux, but they never tell you. Okay, so the amount of methanoic acid produced as the reaction progresses can be monitored by the titration with aqueous sodium hydroxide. When I read the first time until NaOH, okay, I be honest, I'm like, NaOH is base. And then you form a methanoic acid, and then you form an alcohol. All right, so don't you think NaOH will react with methanoic acid and methanol? That was my initial thought. But after that, I know that nope, NaOH only react with methanoic acid and not the alcohol. Why? Because you should know that only alcohol can react, alcohol can only react with Na, sodium atom. Okay? Alcohol cannot react with NaOH. I almost tempted by my initial thought. Okay, so just to give you a little bit more information on what happened when I solved this paper the first time. Okay, now, so coming again, the amount of methanoic acid produced can be monitored by titration with NaOH of a known concentration, and we use timophthalin as the indicator. To determine this, the volume of NaOH needed to neutralize the H+ from the catalyst needs to be found beforehand. Then like, oh yeah, the catalyst HCl can also react with the NaOH. So if you want to know the net total, whatever NaOH is only reacting with the methanoic acid, you have to subtract the HCl first. Okay, so let's look at the procedure. Okay, now, so I already draw very nicely. All right, so I will just use a red color pen to, or maybe I go back to orange color pen now, a bit more striking. Okay, now, so step 1, add approximately 150 centimeter cube of ice water in conical flask A. So if you look over here, I draw in blue color pen. Flask A, I added 150 centimeter cube of ice water. Step 2, 200 centimeter cube of 0.25 HCl was added to a 500 centimeter cube of conical flask B. So this is a way bigger conical flask. Okay, sorry, I didn't draw very big, but never mind, doesn't really matter, but it's still a conical flask shape. Okay, but you add 200 of the HCl. Okay, and conical flask B is where the flask interaction that will take place. Step 3, you need to transfer. So look at the blue color arrow. Do you see over here? I'm actually annotating on top of it, so you can see. Okay, so you need to transfer 2 centimeter cube, all right, of the HCl into flask A, and then you start titrating. So please look here. You are currently now, after transferring 2 centimeter cube, you are titrating with the NaOH up here. Okay, so this NaOH is to titrate the HCl, which is the catalyst only. Step 4, add 10 centimeter cube of the methyl metanoate into your flask B. Okay, then you add here. Okay, so you can see the black arrow. Follow the cursor. I bring down here. You add 10 centimeter cube of the methyl metanoate inside. Okay, swirl the reaction mixture and immediately start a stopwatch. Okay, now step 5. After 1 minute, transfer 2 centimeter cube of the reaction mixture from conical flask B into flask A. So that means in this mixture now, all right, where the hydrolysis of ester starts after 1 minute, you transfer 2 centimeter cube into the same flask A. Okay, carry out a further titration of the content of conical flask A against NaOH, and do not empty the contents of the conical flask A between titration. So you can see that this is an accumulative titration process. All right, every 1 minute you transfer 2 out and then you titrate. So you look at step 6, after 10 minutes, all right, or not after 1 minute, every 10 minutes, all right, the time interval is 10 minutes. Every 10 minutes you transfer 2 centimeter cube and then you titrate again. And you repeat this for 6 times up until 1 hour lah. All right, 1 hour, that's 10, 10 minutes of 6 times of 10 minutes. Okay, state which step is used to determine the concentration of H+ ions from the catalyst. Step 3. Okay, step 3 is before ester was added, you only put the catalyst, all right, and you titrate it with NaOH. Okay, part B. The ice water in conical flask A is used to significantly reduce the rate. Okay, they tell you it's used to significantly reduce the rate. It's actually called quenching. Okay, you have to know this word, quench. All right, it also means like to cease as in the stop. Okay, quench is to cease, to stop, to terminate the reaction, which is your hydrolysis of ester. Okay, you want to stop it. Okay, so ice water is a way, all right, to quench the reaction so that you want to find the concentration at that particular point of time. Okay, suggest two reasons why the rate of reaction is significantly reduced when the reaction mixture is transferred to conical flask A. Okay, now first, I said flask A contains cold water, so it will reduce the heat under reflux temperature. Okay, so for me, I think a little bit more deeper because the hydrolysis requires reflux, organic chem. Okay, when you pour cold water, it will lower down the temperature. And if you've forgotten that it requires reflux, room temperature, and you put cold water, you will still reduce the temperature of the room temperature. Okay, so in general, putting cold water will reduce whatever starting temperature that you have. All right. Therefore, the particles have lesser kinetic energy. All right. So when you have lesser kinetic energy, then you will stop the hydrolysis. All right. I mean, lesser kinetic energy, then your weight will also reduce. Okay. Let me see. Can I like prolong reason number one? Particles have lesser kinetic energy. Hence, okay, hence lesser molecule will have energy greater than the activation energy because they have lesser kinetic energy is lower already one. So I make it sound more like a AS paper 2 kind of answer. All right. Why high temperature can increase the rate is because there is more molecule that have energy greater than activation energy. That's why the rate increases. So now you put cold water, you cool it down. So hence particles have lesser kinetic energy. Hence lesser molecule will have energy greater than the activation energy. Okay. The second one I target on the word called large amount. Okay, the first is temperature, the second is quantity. All right, large amount of water. You put 150 centimeter cube. Okay, and every time you transfer two. Okay, now, the capacity of flask B is no flask A. Flask A is having a capacity of 250 because you titrate in flask A and you transfer everything eventually into flask A. All right. So for me, right, in this 250, all right, capacity, 150 is already the cold water. Okay. And after that, you need to add 2 centimeter cube of the catalyst, which is 152. Then after that, if you look down here, you took 6 times reading more. Okay, 6 times reading. So the 6 reading is 6 times 2 centimeter cube lah of the hydrolysis. So it's 12. Now, if you take 12 plus 2 plus 150, total is 164. Okay, total up here, 164. You provided 250. Your sample down there is 164. All right. There is still space, right? From 164 to 250. Okay. That space, you need to provide some space is because you need space for the NaOH to come down. Understand? So it's not to say that you can take 10 centimeter cube of sample every time you take 10 centimeter cube of sample up. All right. If you take so much, then you will have lesser space for the burette reading to come down. Understand not? Okay. So to me, this is my personal opinion. All right. The reason why we use large amount of water is because 150 compared to the 2, whatever I just explained just now is the reason why we use 2. We need to use very little. It's because we need to give some space for the solution from the burette to come down. All right, you cannot be using 10 because if you use 10, which is 5 times more than 2, then the ratio of 150 to 10 is lesser. But now we are comparing 150 cold water, or let's delete the word cold, 150 water to 2 centimeter cube. So it will greatly dilute the concentration of your reactant as compared to 150 to 10 or 150 to 25, because since you are so familiar in extracting 25 out, correct? So if you extract 25 out and title every time, 6 times 25, I think you will probably burst, all right, the capacity of the conical flask, and you will not have enough space for the burette solution to come down. All right. So my point here is, first, I explained to you why it has to be a very small volume for 2, all right, so that you understand that 150 to 2, it's a huge dilution off, all right, or dilution down. Okay. So to me, I answered flask A contains large amount of water, which is 150 centimeter cube compared to 2 centimeter cube of the flask B solution added. The concentration of the reactant will decrease, and hence it reduces the rate. And then I don't know whether, do you still want to continue with the paper 2 version? When the concentration decreases, then the frequency of successful collision also decreases. It's going to sound very much like a paper 2 kind of answer lah. Okay, yep. So that would be my personal opinion. Okay. Okay, so let's proceed to the next question. Now, table C 2.1 shows the reading taken by the student. The titration in step 4 to 7 show the volume of NaOH needed to neutralize both the H+. 4 to 7 is to neutralize the methanoic acid product and the catalyst HCl, okay, because that's where the hydrolysis occurred already. Now, the volume of NaOH needed to neutralize the H+ from the catalyst is the step 3 version, 11.40. Then the volume of NaOH need to neutralize the H+ from methanoic acid at that particular time is called Vt, and the volume of NaOH needed to neutralize H+ from the methanoic acid at the final 60 minutes is V infinity lah. Okay, now I show you the working, all right, and please check your answers. Now, all the readings here are given to 2 decimal place because why? Burette reading are 2 dp. So when you calculate out, please also answer in 2 dp. Okay, now, so first, how to calculate Vt? All right, now, Vt is the volume of NaOH required to neutralize the H+ from methanoic acid, right? Okay, so I show you the working. The first number here, 1.20, is to take 12.6 minus 11.40. Because 12.6 is the total NaOH that neutralizes methanoic acid and catalyst. Since we know catalyst, all right, up at the top right corner, if you cannot see, is 11.4 just now. So 12.6 minus catalyst 11.40, remaining 1.20 is solely for the methanoic acid here. All right, so you take this second reading, 70.70 minus 11.4, then you get all the subsequent answer. Okay, now how to calculate V infinity minus Vt? V infinity is the 60-minute value, which is 14.5. This is 60 minutes. This is 14.5. So you need to take 14.5, look over here, 14.5 minus your Vt on the left. So 14.5 minus 1.2, I'll get 13.30. Then you same thing, take 14.50 minus 6.30, you get 8.20. All right. So therefore, you may pause the video here and check your calculation, whether the answers are correct or not. Okay. Now, the student forgot to take the reading number 5. Identify independent variable, time. Identify one variable that needs to be controlled apart from concentration and volume. I answered temperature. Okay. Reading 2 should have been taken at 10 minutes, not at 13. You're supposed to take the reading every 10. I guess the student was a little bit slow, so he realized it's a little bit too late. Then he just took a reading and made 13, better than nothing, right? Okay, so maybe that is what happened. State whether this result should have been included or not. Explain your answer. To me, it's a yes. It should be included, as the volume of NaOH needed to neutralize the methanoic acid will also be larger. Okay, my G is missing. Larger than that of 10 minutes. Because at 10 minutes, you have less methanoic acid, less NaOH required to neutralize it. At 30 minutes, more methanoic acid form, more NaOH is required to neutralize. So they will increase accordingly. All right. So it actually does not really matter at what time interval you take out samples to test for the concentration. Okay, it does not really matter. So you want to take out at 14 or maybe 22 or maybe 52 minutes is not a problem. It's just that you won't get a more proportionate way of dividing it out lah. Okay, now what I did was come to here. I want to show you the graph you're supposed to plot a graph to show the relationship between V infinity minus Vt and the rate. Now, just for information, I think V infinity minus Vt is actually called rate. Okay, it's actually the rate. Let me write over here. This is actually rate against time graph. Okay, rate against time, if I'm not mistaken now. Okay, now, no. I think it's called concentration. Concentration against time, curve line obtained, something like this. Now, even though they say draw a line of best fit, right, it doesn't mean line means a straight line. Okay, a line of best fit can be really a straight line and can be a curved line. Okay, so for me, I draw something like that. I hope you get something similar as well. Okay, now, reading number 5 was not taken. Use the graph to predict the total volume of any OH needed to neutralize the amount of H plus at 40 minutes. So you look at 40 minutes, look up here, and look to the left. Okay, for my drawing, I got 2.2 V infinity minus Vt. So if you look at the working here, V infinity minus Vt is 2.2. You want the total volume of NaOH. Okay, so hence, go back to the table. 14.50 is my V infinity. You check your own V infinity minus the number on the graph, which I obtained 2.2. That will be Vt. Okay, and my Vt here, which is the volume required to titrate at that particular point of time, which is 40 minutes, is 12.30. Okay, now total volume of NaOH, all right, to neutralize the total amount. 12.3 is only for methanoic acid. Question 1 is HCl plus HCOOH version. You already got HCOOH, right? So hence you can calculate that what is the total amount, right? So this is the amount, 11.4, which is the HCl. 12.3 is the HCOOH. So what is the total amount required to neutralize both? So you add the two numbers, it will come up with 23.70. Okay, so it's quite a working for 1 mark, but I think still quite okay. Okay, now last, it is not possible to repeat the experiment. State whether the data from the experiment is reliable and justify your answer. For me, I said yes, data is reliable as all the values are on the smooth curve or on the best fit line. Okay, try to use best fit line. Okay, but I also put the other version called smooth curve. It's all falling on my smooth curve, as you can see. All right, okay, I hope that will give you an idea on how to answer the question. All right, this will end the discussion. All the best.